Hey there, everybody. What's going on? Today, Devon Dupuis. I'm going to be showing some 5-axis tips and tricks just to kind of run over like a light agenda. What I'm going to be doing is just kind of going through kind of rapid fire tips and tricks that I have. I'm going to do my best to, answer questions as we go on the fly here. But essentially, kind of what I have here is I'm going to go from kind of beginner tips to more advanced. So I'm going to show a couple things that might not be relevant to 5-axis in the beginning here, but certainly tips that could be used for that. And then we'll work our way kind of to some more advanced tips here. So, hopping in there, the first one, and I don't know if you guys saw, I did put this in the link already. This is essentially just a scallop calculator, and this is a pretty basic tool that I kind of built that you guys can play with. So this is in the downloads folder in the description of the video here. And all you have to do when you open it up is just go up here to the sketches that I have and right click on the sketch. And you're going to want to go to just show dimension. What that's going to do is give you a visualization of kind of what I'm showing here. And really, what I'm trying to demonstrate is the scallop height used for different cutters. So if you go to modify on that file and go to change parameters, you'll see that I put a bunch of stuff in here already. So I have like a ball diameter, a step over, an amount, um, which is essentially just the height of my part, distance, and whatnot. But the ones you really want to modify are the ball diameter and the step over. So if we come in here and we change this to zero point 0.5, we see that we reduce our scallop height here, which is indicated by this driven dimension. You see none of these are actually driving anything. That's why they're in parentheses. And essentially what this is doing is just giving me kind of a gauge. We can also move this in 3D to kind of get a visual representation of what that would look like. So if I increase this step over to like maybe 20, we can see that and I hit enter, we'll see that my scallop height greatly decreases, and we can kind of visually see that. Inversely, if we make this like 150, we'll see that we'll get a pretty big scallop height here, and we can also see that on the part. So this is kind of just something I dropped in there. Also, after the stream, what I'll be doing is just putting the files that we're using today in that folder. So not all of them are there right now. Don't freak out, but certainly after the stream, I will put the rest of the files in there. So moving on, I want to show some tools that have kind of recently been added to Fusion, and we're going to kind of go over those now. So I'm just going to close this out. And it's this minimum radius analysis tool. You can find this in design and in manufacture. Um, and all we have to do is go up to inspect, and we're going to go to minimum radius analysis. I already have one turned on. So I'm just going to open up mine here and I'm going to edit it and show you some of the things that this does. Now, this maximum tool radius here, this really kind of confused me when I first started playing with this because I really didn't know what it did. And the more I played around with this, I realized that this is the kind of the max value for our slider. So if we take this slider and we put this to zero point 0.5, and I hit enter on that. Oh, let me not hit enter. We'll put it to zero point 0.5. You'll see that my slider is just going to stop at that value. So as I kind of move this around, I know this is kind of built like a staircase here, but this is just meant to demonstrate visually seeing different radiuses that could be on your part. A lot of times in manufacturing, we want to just know the smallest radius that's on the part, and this is a really nice tool to help demonstrate that. Also in this file, this is created with parameters, so you can go into change parameters and you can actually change. I wouldn't change the number of steps because that'll probably break it, but if we change our radius increment here to something like 0.125 and hit enter, we'll see that that greatly changes kind of what our part looks like and just helps us visualize and play around with this tool and get familiar with it. So if we make this like 1 inch, we can now drag this slider to see all those values that are in there, and I see I do have one radius that's greater than 1 inch. um, Moving on, let's close that out. And we're going to come back to this a little bit later, but this is a part that I've made in the past. Um, Coming into this, machining a part like this, one of the things I might want to see is like a draft analysis. And for me, this is kind of a hard tool to get around, especially if I'm in the manufacturing workspace. I don't have access to that tool. But this accessibility analysis shows me really what my tool can kind of access from a normal, vertical orientation. So in this instance, what I'm going to do is just select my body, and then I'm going to come in and choose a direction. Now, this part has a lot of different directions on it, but this one happens to be normal to my work plane here. And if we go to the top here, we'll actually see it's not because some of that is displayed in red. So I can uncheck this, and instead of using one of these faces that may or may not be planar to my setup, We can open this down and let's open up my origin and we'll use this. So there's my z-axis for my setup here. So now we can go from the top. We can see that nothing in here is displayed in red when we're looking from this orientation. I also happen to have perspective with Ortho Faces. This is kind of my favorite view. I like orthographic when I'm looking at a normal two view, but not really all the time. So this is a great, kind of in between for those views. You can see when I rotate this, we have all these undercut areas on here, and this just helps me visualize what areas I'd be able to machine and what I might need to set up, multi-axis 3+2 or additional setups if I just have a 3-axis. So I'm going to close this out for now, and we'll come back to this part later. Let's hop into this part here. So essentially, what I have here is just kind of a basic part, and I want to show a couple tricks and give a couple examples between the differences on some of the tool paths. So as I come in here, I already brought in my work holding and everything like that, and I created a setup, but I don't have any tool paths. So the first thing I might want to do is rough this out. So I'm going to come up here, grab adaptive clearing toolpath, just drag this out. This is a little tip if you want to see what the names of these pages are. I'm going to go to tool here. I am using the new tool library. So if we come in here, I might have a problem, finding my tool here, but we can come in here and pick this. We can also go into the constraints on the right and filter this down. And we'll do that some more on some other tool paths. So for this, I just want to change my geometry. I'm going to change my tool orientation to the side here. And then what I'm going to do is I have no machining boundary, and this is kind of what I want to talk about. So if I just hit OK on this, and let's change some of the parameters before we do that. So we have a face mill, so I'm going to go 1.8. It's 2-inch face mill. We'll cut down at 0.200, and we'll leave these at 0.200 because I don't need all that definition. I'm going to hit OK here, and this is going to generate some roughing passes around my part. Now, I can see this immediately starts, kind of in my vise here. So there might be some ways to get rid of this. One of the ways that is probably a common misconception is when we go to this edit page, I do have this added as my fixture. But essentially what this is doing is adding these bodies to my simulation so I can simulate collisions. It's not necessarily going to make your toolpath avoid them. Let me come in here. So what we need to do is create some sort of boundary. So I'm going to go into manufacture, I'm going to go from manufacture to design. I'm going to create a sketch here, and I'm going to pick this face. Now, my Fusion, I just have it default to not project faces because I do a lot of manufacturing. And generally, I don't want a lot of noise in my sketches. So that's why I don't have this face in there. That's something you can turn off and on preferences. And if I did want to project that face, I would just hit P, select this face or the body, and then project it. In this case, what I want to do is make a rectangle, and I'm just going to make this rectangle really large. Now, the reason this is because I want to cut inside of this boundary. And if I only have a single boundary, I'm only going to be using that boundary. So what I'm going to do here is just add another one. So I'm going to come over here and I'm going to grab this area and kind of draw a box, or just a crude box around my vise. So with this other boundary, we're going to do some things in that adaptive clearing toolpath. So I'm going to hit finish sketch here, and we can hop back from design into manufacture. And what I'm going to do is right click on this, hit edit, and we'll go up here to machining boundary. Now I'm going to turn this to selection, and I'm going to select both of these lines here. Inversely, because I don't have any other geometry on this sketch, I could also just select the sketch. So if in a later date I want to change or modify this or even add other areas that I want to keep out, this toolpath is going to automatically update when I regenerate it with those changes added to my sketch. So I can turn my sketch off now because I don't need it anymore. But the one setting I want to look at is this tool containment. Really with this tool containment, I want to stay inside of my boundary. So I created this kind of large outside bounding box, but for this box I drew here that is close to my vise, I want my tool to stay out of that. So I'm going to say tool inside boundary because then it's going to stay in between these lines and it's not going to go inside that inner boundary. So now when I hit OK, we can see that this is going to go and avoid those areas that I don't want to machine smashing into my vise. So if we right click on this and hit simulate, we can now start to visualize kind of that process. We can turn our stock on here, set this to material. These are kind of some of my favorite settings usually when I'm simulating. And we can see here, and we can also turn on the stop on collision, and this will just show me any collisions if they happen, and they'll stop. So this is just going to run through here, kind of rough that out. So I might want to drop this a little bit more to continue. So I'm going to come in here, edit. We'll go to heights, model bottom. Let's just make this minus 0.15. And there we go. So moving on from this, there's a couple ways I would machine this top. Now we do see that if we look from this face, this front face, that some of this stuff from the top orientation is kind of undercut. So a couple things we might normally do is come over here and make like a flow toolpath. And we're going to get into this a little bit more later. But if I come in here and pick a tool, we'll see that this might not be the best solution. So if I come over here, let's go milling, ball, and pick this half inch. And if I come in here to geometry and I pick these faces, we'll see these might line up nicely. So if I come over here and I say that I want to have, let's just put 15 passes just to see. I want to use multi-axis and I'll worry about changing my sideways tilt because I wouldn't want to machine with the bottom of the tool for this. And we can hit OK. These might not link together very well based on my geometry, and I'm seeing that here by some starts and stops. So although the tool path looks fairly clean, we have some things that are going on here that we can fix and make a little bit better. The other problem with using flow is this surface is curved. So if I wanted to stay more of like a traditional kind of fourth axis toolpath on this, when I hit simulate, I'm going to turn my stock off just to visualize this. From the side, we'll see that my tool is not always normal to a specific axis. So I am getting a lot of movement there. And in this case, it's kind of breaking up. The reason that is because some of these UV vectors can chain together. And again, like I said, I have a demonstration at the end that will go over this to kind of show you how to take a look at those things. So what I'm going to do is I'm actually going to come up here to this rotary toolpath, and I'm going to use rotary. Now there's some things that we have to do in here, and these are some settings that are kind of new to everybody because this rotary toolpath is fairly new. So for my rotary axis, I'm going to come in here and we can choose something. So I'm going to say rotary axis, and let's just pick this. But we see that my rotary axis still isn't really displayed in the right orientation here. So for my origin, let's just use selected point, and I can come in here and just select a point like this, or we can select even a point here, and that's going to adjust my edge there. Oh, and I picked that wrong, so let's repick that. And then for my edge, we pick this, or we can pick kind of a point up here. And now what I want to do, if I just hit OK, this is going to go all the way kind of around the part, which obviously is not my intention. I would really just want to machine kind of these curved areas. So one of the things that I'm going to do is come back into here. We'll go to Edit. I'm going to change this to circular. And then what I'm going to do is go to Geometry. I'm going to come over here to Set Angular Limits. Now, I want this not to be full 360, so I'm going to come in here and just say Specify Endpoint. And I'm going to just pick a couple points. So let's pick here, and let's just pick here, for example. Now, sometimes when we pick that, we might pick it the wrong direction or Fusion gets confused, and it might pick a direction like this. So this kind of colored in area here shows what angles we'd be working with. And obviously, for this situation, I would want the opposite selection. So I'm going to check this flip sector. Um, and now we have the correct orientation here. So now I can hit OK. And based on that origin and everything that I set up there, now we have a fairly smooth fourth axis toolpath on this, even though this could be in a fourth axis machine, a five axis machine, and now we're staying kind of normal to that surface from the side, and we're not getting all that, kind of volumetric error with moving all of our rotaries at the same time. Let me just take a look at my notes here. Um, there was one other thing I wanted to show that was kind of fairly simple. So with this, let's pop back into here. Um, One of the things that's a trick for some of the toolpaths, and I'm just going to draw something real quick because I must have forgot to save it. I'm going to make this just a block 4x4. We'll hit E for extrude. I'll make this 1 inch, and then I'm going to come over here and I'm going to hit P for project. I need that face. I'm going to close this out and use my offset tool here. I'm going to offset this face just in maybe like minus 0.15. I'm going to hit E for extrude again and minus 0.75. And I want to actually put some angle on this. So I'm going to say edit feature, and we'll make this 20 degrees this way, so minus 20. I'm going to add some fillets here, and this is just to kind of demonstrate workflow that I do sometimes. And we'll come in here, make this 1 inch. Point 0.6 is a little bit better. And then I want to add a radius or a fillet at the bottom here. So we'll put 0.125. So sometimes we could obviously machine this from a three-axis orientation. And I want to talk a little bit, my friend Rob Lockwood's talked about this before in the past, and wanting to do five axis and kind of needing to do five axis are two different things. So in this situation, if we were to kind of do five axis on this, we would either be doing like a single swerve cut to save time here, or if we're doing a traditional kind of step down with multi-axis movement there, it's really kind of unnecessary, but I know it looks good in those Instagram videos, so we're gonna do it anyway. Um, so we're gonna pop into Swarf, and normally what we do is we'd cut this in a single pass. So if I go to Autodesk demos here, we'll grab this end mill, and this is my general selection. So a lot of people have issues with doing this. So for my selection mode, I don't ever really do faces. Certainly you can get good results with this, but I either do manual or contour pairs. So in this case, I'm going to do contour pairs, and really how we choose our direction, and to make this really simple, is we just want to choose the bottom first and then choose the top. So I'm just going to choose this bottom segment and then choose the top. So I really want to see blue at the bottom and yellow at the top. This will signify my direction, and it automatically figures out my what side my tool needs to be on. So normally we'd come in here and we just say OK, and this is going to make a single kind of swarf toolpath on here. So if we hit simulate on here, we can see that this comes around and it cuts with the side of the tool, and that's fairly easy. Um, it's one of the things that's really nice about Fusion. But if we wanted to change this to a different toolpath, maybe we want to have a ball mill or something like that, I'm going to duplicate this, come into my second one here, and I'm going to change my tool. So let's go to demos again. We'll go milling, ball end mill. We'll grab this little guy. And we'd get a similar result right now if we just hit OK. But the one thing I want to show you is sometimes, and this obviously isn't needed for this surface, but this certainly could be used in situations where needed. If I go to passes here, I'm going to change this cutting mode to spiral. And then on here, I'm just going to make this bigger just for generation time. I'll put in point 0.1. And now we can hit OK. Now, this is obviously going to spiral around as it goes down. So not just taking that single pass with the side of the tool like you're probably used to. One other thing here is if we hit simulate and I play through this, we'll see that we're obviously cutting with the side of the tool when we do this, but we might want to add some tilt, because in a situation like this, I wouldn't necessarily want my cutter to be touching that whole part. So let's come back into here. And for my passes, I'm going to go to sideways tilt, and we can put in something like 30 degrees. And sometimes I'll mess this up. And it looks like we're having an issue with our lead in parameters. So we can kill that just to get rid of this. So we'll just turn these off and hit OK. So now we don't have a warning. But now we can see we're kind of leaning the tool away from that surface. So if we hit simulate, instead of the tool being aligned with that surface, what we have here is the tool, pointing away from that surface by whatever amount here. And then we can always change kind of see how the tool kind of wanders back and forth as it goes here. We can come in here into edit, go to geometry, and sometimes I just put this to constant slope. But certainly you can try out the other settings to see if you get a different result. And here, if we hit simulate, we shouldn't get as much movement there. So now we're really only moving in the corners, and it's not doing as much kind of back and forth on that. So I think we're done with that. Let's move into steep and shallow. So one of the things I want to show kind of with this steep and shallow, let me open this up, is we can do some really cool stuff like this. So I'm going to show kind of a little bit more complex example, and then we'll move into how some of these settings work. So this is a part I was trying to do in Fusion about 6, 8 months ago. I was having a lot of issue with getting to machine some of these blade faces in here. So I was trying toolpaths like blend, which does okay, but it's hard to constrain this down. Flow, kind of a similar situation. A lot of noise in those toolpaths. Parallel is okay, but I had to manually come in here and make my tool orientations. Swarf was kind of the same thing. It just wasn't respecting the part because it's really only seeing the rails that I choose to drive my toolpath with. So in the end, for the customer, we kind of decided on just doing like a combination of the two blends here and crossing it kind of in the middle, and then patterning those around. Um, But with this, so this is steep and shallow, and this we're going to go into this a little bit more, but this is one of the things you can do with the new steep and shallow toolpath. So if I come in here into simulate and we hit play on this, we'll see this does a really good job of machining, and there are obviously some undercut faces on here. So if I look kind of normal to that surface of my toolpath here, and we drag this back, we see my tools cutting, underneath my part here and going over, kind of making this pretty difficult part fairly easy to do inside of Fusion. So I'm not going to walk through this kind of complex example of how to do this, but let's go back into Fusion and look at some things that we can use that for. So I'm going to come in here, I'm going to say create sketch. I'm going to make again my standard little 4x4 rectangle. I'm going to hit E for extrude, and we can make this 0.125. And I'm going to come in here and put some fillets on the corners. That's fine. So this is going to be the surface I'm machining. Now I know this isn't multi-axis, but I want to show you some of the ways that we can use the tool axis controls in steep and shallow to give us that motion, whether we need it or not. So I'm going to come in here and I'm going to make an offset plane on this face. Let's lift it up. 3.5 inches. And I'm just guessing at this, so most of the time I would be coming back. But I want to show another example of this too. And I'm going to make an offset plane underneath this. And you don't have to do this. This is just for me to show two different kind of examples of this. So we'll drag this one down. I'm going to create a sketch on this face. And I'm going to put just a point. So we'll keep it real simple. And then I'm going to drag up to repeat that sketch. And I'm going to put the same point on that lower level. Get some display issues here. And I got it. So I have 2 points in here, and let's just turn my second sketch off here, just because we're going to work with this first one to begin with. So I'm going to go from design to manufacture. Let me just create a simple setup. Use fixed size, round up to near zero is good, and hit OK. Now I'm going to go into the steep and shallow, and we'll drag this out just to show that new toolpath page. Start with picking my tool here, and we'll go to passes. Now I'm going to put this to scallop and let's just hit OK and just see what kind of toolpath we get. So generally this is kind of my workflow, especially if you're new with getting into 3D toolpaths, just to kind of see what Fusion generates and then we can constrain it down from there. So in this case, I see just for visualization, I want to have a bigger step over here. We'll put in point 0.1 and hit OK. So this is going to be kind of the path here we're going to manipulate. So if we right click on this and hit simulate, we'll see that this is just a straight up 3-axis toolpath. So we don't have any sort of motion here. If we right click on this now, go to edit and go to tool axis, under this tool axis here, we can say from point. So in this instance, I'm going to want to go from a point. So I'm going to then now pick this point. And now we can hit OK. So this is going to generate, shouldn't take too long. And then we can kind of right click on this and see what we got going on here. And it looks like we have some sort of issue. And this happens from time to time. So let's say from point, orientation, and we'll try a bigger threshold angle here. We'll grab this. Oh, let's just try it again. And if it doesn't work, we will move on. So come in here from point, grab this, and we'll hit OK. And we should be generating the toolpath kind of based on this point. Now, it looks like there's something going on here, so I'm not getting the full kind of expected motion that I want, but certainly you can come through here and we can try this with a curve and come in here and say create sketch. Let's turn on this first one. And we'll just do kind of a basic line. See if that works right now. So here we're going to say from curve. We're going to pick that curve and we'll hit OK. So certainly a better result here, and it looks like we must have some sort of other forces kind of pulling on our toolpath here. So those are certainly things you can come in here and go through and adjust. But if we look at this blower motor, I mean that's really all I did here was I came into here and I put just a single point. So under tool axis here, sketch point, I'm just using this point, and then my tool is always pointing away from that. So when we simulate this, we see kind of those the tool is always staying connected to that point. Now, let's go through some other ways that we can use kind of steep and shallow to go over for some tricks to use to our advantage. So in this 5-axis parallel here, really what I've done is just take a simple, a simple operation that, like I said, 6, 8 months ago, I wouldn't have been able to do inside of Fusion. And now we can do this. So coming into here, if I look at this toolpath and let's just simulate this, all I did was just take steep and shallow. I turned a really high angle for the difference between the steep and the shallow. So essentially, we're just telling it just to do a shallow pass. And so all I'm trying to do is a parallel on the bottom surface here. And when I go ahead and hit play here, we'll see that this does a pretty good job of staying away because I just have automatic collision avoidance turned on. And I'll show you kind of how these work. But one of the things that's going to happen here is when the tool can start to kind of stand itself up, we'll see it's starting to do that. So here, when we go on these passes here, we'll see the tool standing straight up, and then it kind of jerks to the side here to get out of the way so it doesn't collide. Now it's doing what we want, but it's not very smooth, so it might not look really good on our machine. So if we come in here, all I really did was change a setting here, and let's just go in here and show this. So over here, under this smoothing distance, I put in just 20 inches. And now what this is going to do is essentially those moves that would kind of be herky jerky, it's going to smooth it out over a greater distance. So the smooth distance on the other toolpath was at 200, and this is what it looks like with 20. So if we come in here and hit simulate, play through this, see, this is going to do a really good job of kind of being smooth and maintaining, that tool path and looking really good on the machine. And then eventually, what it does in the center that really kind of surprised me is right here. It's switching to kind of a 3+2 fixed orientation because we really don't need all that motion, and this is really would run a little bit faster in the machine, and this would certainly look better without having all those rotaries moving at the same time. So all I did in these toolpaths, so we come in here and we go to edit. And we look at this. You can turn on a slope containment. It's really not needed, but you can certainly do it this way. But on passes, this threshold angle, you can bump this up to be like 89. You can't quite set it to 90. But essentially, what we're doing is we're just trimming off steep passes at that point. And I just set kind of a larger step down. So if you get a little bit of noise with your boundary selection and you're getting, kind of upcutting on the steep areas, you can just set this to be a little bit larger, and certainly you can adjust kind of what your boundary is, and then you'll get kind of these smooth results. So that works with doing a parallel, and it also works with scallop. So scallop is the other setting that we kind of have in this toolpath. So under passes here, we have um, scallop and parallel, and you can choose whether it's going to go one direction, both ways, or the other way, which would be the opposite of the first direction. And you can use those settings to kind of to your advantage. So another pretty smooth solution here would be to have it set to parallel or have it set to scallop. I'm sorry. And we can see this kind of moves around just going from the outside to the inside, and really it's really smooth, and it would look really nice on the machine here. Um, All right, so I'm gonna move into another part, and this is gonna be like kind of a corner pick. Now, this is something that I used to do a lot for, machining corners. So especially when you have a really tight radius that maybe you have an 1/8 inch radius that's 6 inches deep, it's really kind of a pain to machine those features sometimes because certainly. A 8, 10 inch long tool that was 1/8 of an inch isn't going to run very well or sound very good in the machine. So there's a lot of things we would try to do 3+2 positional to get this to work. So let's go from design into manufacture here and look at some of those things. Now, a lot of people might try to use a toolpath like Flow and just change the tool orientation. And initially, this kind of looks good. The problem with this, though, is it's really not doing what we want. So if I right click on this and hit simulate, Well, see, this is going to kind of stripe back and forth. And really, the reason this is now, I drew this in Fusion, but it's because the UV vectors are not connected. So once it does this side, it's going to flip and go to the other side. So kind of does what we want, but really not in a very smooth motion. So if we go back into Fusion, we can go to Design and take a look at why that is. So if I right click on this body and let's go to Texture Map Controls, here we'll be able to change the display mode to UV Diagnostic. And what this is going to let me do is see the UV vectors on my model. Now, I see that the grid kind of lines up, but really the issue here is my directions are changed. So my U is going one way here and my U is going the opposite direction here. That's displayed by these red and these green lines. So although the grid and everything lines up and I have a fairly decent surface, these aren't these aren't chained together very nicely. So I could mess around with trying to make another surface or getting this to work, but really we have a couple other options. So that's why it flows. And if we go in and make another flow toolpath, you guys will kind of see what's going on here. So if I go to geometry and I pick this face, and this face, we see it grabs the faces, but they're not all the same direction. So a common, thought would be, oh, I'll just fix this direction here. But really what I did was I just reversed this direction here. And although these two might be able to line up, it's not going to connect them very well over here. So, because if we change to a long U or a long V, it's going to flip those directions. So, what do people try to do to fix this? Maintaining that kind of or tool orientation that we have, they might try to just do a contour toolpath, so like a constant Z level. And this gives us okay results, but not really what I want. It looks kind of weird here, kind of almost like a fingerprint, but it is doing its job. So from our tool axis normal, what it's doing is it's doing a really good job of doing a slicing toolpath. So it's just slicing the model and laying a toolpath wherever there needs to be contact. Now, some people might also try a parallel. Now, parallel initially looks kind of good if you look at it from the tool orientation, so it's doing its job by striping across, kind of doing a raster, style toolpath there. But the issue here is that on one side it's good, but on the other side it's just shooting up diagonally. So it is doing what we told it to go, based on our tool orientation here. But that's not a good result either. So I'm using here the blend toolpath, and I have kind of a wide step over just to kind of demonstrate this. So using that tool orientation, what we're doing here is blend is a different type of toolpath, and you can find this by going to your name, going to preferences, and enabling the preview for blend. Now, this is still in preview, so there might be some things in there that we're still trying to work out. And certainly when this is officially released, it'll be, in the 3D toolpaths like you see it here. Um, so if we make a new blend toolpath, just to look at kind of some of the selections here, this toolpath works a little bit different. So it's not a projected toolpath where we're looking from the top down at something, or a slicing toolpath like contour, where we're slicing the model and laying toolpath, where we kind of can. What this is doing is it's actually taking our curves and it's offsetting them on our surface. So if I come in here and I pick my drive surfaces like this, I need to be able to morph from a set of curves. So I'm going to come over here and I'm going to grab, I wouldn't want this close selection. So I'm going to hold down Alt. I'm going to chain this and then I'm going to pick this to here and accept that contour. And then I'm going to grab this one down here. And it really doesn't matter what side you pick first, and hit OK. Now, essentially what this is going to do is going to take our surfaces here that we have selected, and it's going to take these drive curves that we have and it's going to lay them on the surface. So this is doing a lot of really cool things, although this is kind of a more prismatic part, but this is laying that curve on top of the surface to kind of direct what our orientation would be. And I'll show a little bit better example of this kind of here on my last part. Um, so with that tool orientation and everything selected here, we have that toolpath being blended really smooth, going back and forth. If we hit simulate, we can see that. So it's going back and forth. We could change it to be a single direction, which is would most likely be what we'd want, and we would get that result. Now, the last thing here is sometimes my tool gets all the way down to the bottom, and I don't like where it contacts. So essentially, what I did here is I made a blend with a ball. Now, I'm going to talk a little bit more about this, but if we go back to my model here, I did make kind of a little ball here with an as-built joint. Now, this is the way I used to do it, but there actually is a lot easier way to do this. So essentially what I did was I just came in here and I made a sphere and I put a hole in that sphere. And then with my timeline being turned on at the bottom here, I made an as-built joint, and that as built joint would allow me to kind of position my ball and then just tell Fusion that it's in this position I want. And then I can make it a ball joint where I can just move this around. So what you can see here is if I grab this and I kind of just move this in my assembly here and I adjust what this orientation is, I can turn this ball back off. But when I go back to my toolpath here for this blend with the ball and I right click and I hit generate, you'll see that my orientation is going to update based on whatever orientation that ball is. So an easier way that I've kind of found recently, instead of making a bunch of geometry, we can have Fusion kind of just make this for us. So we're going to run through that process again, but I'm going to show you the easier way. So I'm just going to come in here, I'm going to say create, and I'm going to create a new component. Now I'm going to hit OK, and this component's going to be down here, and it's automatically activated it because that's what I had selected. But let's just put in here tool orientation, and I'm going to turn my main back on here, and we have this orientation here, but there's nothing in it. There is actually an origin here. So I can't make like an as-built joint with this because really I don't have any features to kind of pull on this, but I can right click on this and just say move copy. Now I can move this over so it can be visually a little bit more of kind of what I want, and let's rotate it this way. And essentially what I want to do is just tip my z-axis away from there. So let's start with just kind of a light orientation. And I'm going to use the z-axis on here and the x-axis also to kind of control what my path is. So if we come in here and hit OK, I just moved it around and I'm going to leave that on. We'll hop back over to manufacture and let's just create a simple parallel toolpath and show how this can work on some other toolpaths, or you can use your imagination to take this as far as you want. But let's go to geometry here. I'm going to pick a selection and we'll pick, let's just pick from the bottom here and we'll chain for this whole area. Now, on my tool orientation, I'm going to use that orientation that was made for my component. But not only selecting the Z, I'm also going to select the X. Now, what the X is going to do, it's actually going to control what direction my passes go. So if we come over here, we'll say contact point boundary, and we have our ball mill on, and let's just set this to 250 is good. So we see we're getting that kind of, the passes on our part. We could certainly tighten this up a little bit, which wouldn't be needed. This is just for demonstration. But if we put in here, 20 thou, we see we're getting a nice tight toolpath. Now, if I look at this or I simulate this through and I see that this isn't really what I want, or I want to correct kind of my tool angle a little bit, all I have to do instead of coming in, instead of trying to, mess around with, making something or drawing lines or doing like a spike ball like before, we can just go to design here and we can right click on this and just say move copy again. And we can take this handle and just drag it down. And so now I'm just moving the position of that component and I'm going to go back to manufacture. We have our old parallel here, and this is another kind of little quick tip that I do a lot when I'm making toolpaths like this. When I'm trying to see the difference, I'm going to leave that one as it is, and I'm going to duplicate this. And I'm going to take the second one that was duplicated, and I'm just going to hit generate. So we'll see that this one is kind of our new orientation, and this is our old orientation. So now we could simulate this through and kind of look at the differences and choose which one we want best there. So that's pretty much all I have for that. Let's move into the last thing that I have here. Is this kind of UV vector example. And really what I've done here is there's a lot of things going on, but machining this would be we'd run into similar, issues with that corner pick. So if we look here at our parallel, we have another tool orientation here. We're just kind of doing a parallel that's striping across. Now here it kind of looks like a fingerprint, which really isn't my desired result. We could change that to a contour, and this I would say even looks more like a fingerprint because it's just slicing the model from our tool from our z-axis. Now, if we switch to a flow type toolpath, which might be a common thing for a lot of people to try to do, um, we see that we get kind of a weird direction here. Now, this might work, but if I want to have a nice surface, most likely I'd want to flow from left to right. And flow really isn't giving me a good example of that. So if I turn on my two directions that are possible, these are the only two outcomes that I could have. And obviously they're both turned on right now. So I'm constrained to either this direction or this direction. Again, we can pop into design and we can open up this body and we can say texture map controls. And if we change this to UV diagnostic, we can see those directions here. So really with a flow toolpath, when I look at my settings, I don't have any choice over what kind of orientation my pattern goes because I'm really constrained to just along the U or along the V for my direction. And changing that is only going to give me these two results. So what would I want to do? This is where that blend toolpath comes in pretty nicely. So if we look at this first example of blend, we see that it looks kind of weird. And the reason this is because it's from a traditional kind of z-axis normal here, and it's using the same settings that the other two are. And we can go into those, but this is actually has an undercut right here. So if we come over here and look at that accessibility analysis, and we hit my part, choose a direction here, we see there's a bunch of area in here in red. And what that means is from our z-axis normal here, we wouldn't be able to reach those faces. So if we have a multi-axis machine, we can just simply correct this angle. Um, and we'll do that here with this blend toolpath. Now, if I come in here and go to edit and we look at my selections, I just chose one single drive surface. And then instead of being constrained by our U or our V vectors, I just chose these curves. So I want it to morph from the top to the bottom, basically in the direction that I chose. So we could use those. And essentially what we'll see is when this generates, if I look from the front view, we see kind of a diagonal toolpath. And some of you might be confused, and by all means, there's a lot of times that I was also. But the reason this is looking diagonal like this is because of our tool contact. So if we come in here and hit simulate, and we can hit play, and then we can just drag this, we'll see that if we zoom in here, my tool where it's contacting my part is actually staying the same. The toolpath visualization that we're getting is from the center line of the tool. So if I play this you see as it goes across the part, it's actually raising up, which is giving me kind of that visual look of my toolpath being diagonal. But actually, because of this undercut, the contact of my tool is actually contacting just on that one point. And we can turn on our stock here just to show that. So playing through this does a really nice job, but again, this is 3 plus 2. So what we could do here is we can come over here to this blend, go to edit, and we can turn on this use multi-axis. Now, we might want to adjust what angle our tool is kind of contacting this at. Here, because I have kind of a compound, I'm using a tool orientation and a direction. I am not cutting with the tip of the tool, just based on what I'm doing here. But if we wanted to use multi-axis, this both ways is going to be one way we could do this. But there is a problem with blend at the moment. So if we right click on this and we hit simulate, we'll see this is going to go both ways, kind of like I told it. And we'll turn this off just for performance. So this is going back and forth really nicely. But on a mold part or something that needed to be smooth with a nice look, I generally wouldn't want to go both directions here. So what we would do is come over here to blend, and we would just turn this to be one way. So if we go one way on this, the problem with giving any sort of sideways tilt or whatever with blend is that the tool is going to flip flop. So if we come in here and we give this a sideways tilt of, let's just say 30. So we want to tilt the tool 30 degrees away from the surface. We'll see that when we simulate this, and it looks really noisy because it is, this is actually going to flip flop back and forth. So it's going to go that way and then flip the other way, which is really not a desired result that we would want. So to correct this and really get the result we'd want, we'd come in here and we just turn this to one way. And then we'd have to play around with our sideways tilt, either positive or negative, to get our desired tool contact. So we can see this would be probably more like what we'd want. And this is cutting opposite the direction, so we just have to flip it. But this is just going the one way, and the relinking moves would correct all that. So let me see if I can pop into the chat here. Is there any questions? Does somebody want to Slack me if there's any questions or anything that we could go over here at the end? Let me take a look at my phone here. One second, guys. And it doesn't look like I'm getting any questions here. So certainly, like, comment, on the videos. If you guys have any other questions, we'd be sure to, try to get back to you. All of these files I will put um, in that Google Drive inside of the description. And then, yeah, so Thanks a lot for coming by, guys. A lot of the stuff that I wanted to show you today was just kind of some, rapid fire tips and tricks, kind of stuff that I use to, get work out the door a little bit faster. And yeah, we're glad you came by, and thanks for using the Fusion 360.